So this was number 3, where we had to come up with that equation by simplifying the fraction that we add on. Give it that's 120 pound male. Male had 3 drinks, and since he's male, he's got that 0.68 factor. And so in class, we calculated these numbers and we graphed it by hand. So the next step, if you hadn't done that, is to do that on the computer here. So let's see if we come in the right one. So minimally, you want to do hours for 1, 3, and 5, just like the table, but you can fill in any hours you want. So I just decided to do 1 through 6, and then I threw an extra one just for fun in there. And when you set that up, you want to, it's a calculation for the BAC, so what you got to have equals first minus 0.015 times the number of hours, whatever you have here, and then add on that approximation we had. Now, I just typed the 0.104. You could have done the whole calculation right there. So there's 2 different ways you get around that. Maybe any questions about getting back to that? And once you type that in there, you can just fill it down. So I'm just going to start that over just for fun. Spreadsheets. So I'm going to start off with 1 hour. You get the BAC, it's equal to negative 0.015 times the time, which is right next to me here. So I just click on it. And then I add on that fraction. And you can either do the fraction that was pre-calculated or calculated on the fly. If I calculate on the fly, it's going to be parentheses to start the numerator, 2.84 from our formula, times the number of drinks. How many drinks was it here? 3. Close the numerator, divide, parentheses, start the denominator, and then his weight was 120 times the gender factor, since he's male, is 0.68. So I'll get about the same number. It's going to show me way more decimal places, and I can always choose to see less decimal places, which is like rounding. Now, as far as the 1 goes, I want to see 2 and so on. And so once I get the 1 and 2, remember we can do the autofill to continue the pattern. So I can get a few numbers there. And then for the BAC, I just click on the formula and then use the autofill button to drag it down. And so I can see after about 7 hours, it'll be pretty darn close to 0 for the his BAC. So and as far as the difference in every hour thing, that was just something I was playing with yesterday. We really don't need that here. Get rid of that for now. And I started a tab for the female, but that's not part of this. You don't have to turn that in. But I'm going to use that anyway to answer some questions later on. So any questions on getting 120-pound male spreadsheet going? So this is all I needed you to do and submit. Oh, what am I missing? I'm missing something. A graph. Yes, okay, let's do a graph. So if you're a Google Sheet user or an Excel user, you highlight all the data that you want to see. And maybe you have less numbers than me. That's okay. As long as you have 1, 3, and 5 minimal. And then I can either hit the graph button, if you can see that button on your screen, or you're going to go to Insert, Charts. I'm going to zoom out so I can see it. I'm going to do that in 2 different ways. So one, we could look at the table and try and guess at it. And we could also use an equation. So let me get my table in there, my chart in there, and then we'll do that one. So Google picked a column chart. Excel will probably pick a column chart too. For kind, I want a scatter plot. And then it just plots those points nice. So we can see that straight line we had yesterday. So my graph is in there. And I think the titles that it picked based on our headings are reasonable, so I'm not going to change those. I'm just going to go. So if you did this in Google Sheets, then you can just hit the share button, copy the link. If you don't see the link, hit get shareable link, and it'll show you the link, and you'll submit that in Canvas to check out. If you did this in Excel, you'll have to save the file somewhere, and then you'll have to upload that file into the submission in Canvas. All right, let's move along on the worksheet. Emily has a question. So number 8, is that right, Emily? Okay, so 8 says, how long will it take for the student's BAC to be 0.08? So I'm going to do that in 2 different ways. One way is by using the spreadsheet. So I can look at the spreadsheet and I can see it's 0.089 at 1 hour. At 2 hours, it's 0.074. So somewhere in between 1 and 2 hours. So I can approximate the answer there, and I can say it's going to be maybe an hour and a half based on my table. So that's one possible answer you could write down. Another way to do it is we played around with solving equations last term, so we can write it as an equation and solve it. So our formula is that the BAC here is equal to 0.015 times the time plus that 0.104. So we want to know when the BAC is 8%. So we're just going to write down, what do we want the BAC to be? 0.08, so that's the BAC. And my formula says the BAC is equal to negative 0.015 times the time plus that 0.104. So what we're going to do is, by plugging in what we want the BAC to be, we're going to solve this to find the time. If I want to isolate the t here, what do I have to do first to the right side of the equation? Can I get rid of the multiple or the thing that's added on? Yeah, get rid of the thing that's added on first. So the first thing I want to do here is from both sides, I'm going to subtract 0.104. And calculator is a great thing to use right now, so whip out a calculator. What happens if you do that subtraction there? We're going to get a negative something. 2.04? 0.204? Yeah, okay. So that comes out to negative 0.204. And that's equal to negative 0.015 times t. Okay, how do I get rid of that negative 0.015? Yeah, divide by it. So next we'll divide by it and whip out our calculators to help do that. 0.5 divide by the negative 0.015. Okay, so now ask your calculator, what does that division right there give us? What do we got? What's wrong? It's a negative over a negative, so it should be positive. And it should come out to something between 1 and 2. So whip out calculator 2. So I've got that negative 0.204. Oops, here. Negative 0.204 divided by negative 0.015. Whoa! That's something wrong there. Okay. Well, shouldn't be 13 hours. Okay, so we had a mistake somewhere. It's supposed to be 0.24. Okay, let's check that. So I had what? 0.08 minus 0.104. Is that right? And that should be 0.024. Oh yeah, that'll make a big difference. So if we take that number and divide it by negative 0.015, That should give us something more reasonable. Okay, 1.6. So I was guessing 1.5. I look at my table. Computation comes out to 1.6. So that's more like it. So good that we were able to estimate and see our first calculation was wrong because I wrote down the wrong number. So let's clean this up. So this subtraction here should have been 0.024. And then when we divide that, we get 1.6. So 1.6 hours seems more reasonable based on our table. So that's the other way to do this. We can do the same thing for the next part, because the next part says how long will it take till his BAC registers as 0. So we can either look at our graph, and our graph says it's going to be around 7 hours. We can also calculate it. So let's do that calculation. So again, our formula says the BAC is negative 0.015 times the time plus 0.104. Next question was, when is it 0? Is that correct? Mm-hmm. Yeah. So I'm just going to plug in a 0 for the BAC and then fill in the rest of this and solve just like before. So like before, first thing we'll do is subtract that constant part, the initial blood alcohol level. Cancels that out on the right. On the left, 0 minus something is that something. So that's going to give me negative 0.104 equals negative 0.015 t, and then we do our division. And that should be a little less than 7. Anybody got a number there for me? I was guessing 6.9-ish. Class. Got 1? Oh, we got to clear that. 6.93 roughly. So this says it's going to take about 6.93 hours for that to happen. So a little under 7 is what it can. And either way is okay. We do want to practice solving equations. All right, other questions from the worksheet. Spreadsheet for which one? For the females. The female spreadsheet, okay. All right, so I did make a spreadsheet for the female. That's optional. You didn't have to, but you had to fill out the table and the chart in the worksheet. So let me just first show what's going on there. So on this one right here, we have a 110 pound female, and this formula is already cleaned up for you right there. And so here we're letting the number of drinks she has vary instead of the time. And so what we want to do is we want to plot that for a few drinks. So I did that on the spreadsheets, my second tab here. So the formula I typed in is the one given at the top of problem 9. So I've got for the BAC equals negative, let's blow that up again, 0.03 plus, since the numerator is complicated, put it in parentheses, 2.84 times the number of drinks, which I click over here to get, and then divide by the 60.5, which is the cleaned up weight times your gender factor. So that's for one drink. So again, since the formula references the one over here, formula down, and it says 2, 3, 4, and 5, and so on there, it'll just automatically make those calculations for me. So do you have similar numbers, or? Okay, so show me your formula for 0 drinks. All right, so Yeah, equals negative 0. Oh, there's no times. You get the times wrong. Yeah, so get rid of that one. And where you have the one from one drink, that's supposed to be the cell. So look at that cell there. Okay, that's right there. On this one. Yeah, so it doesn't make any sense. It's trying to measure proportion or anything. Just me. Any other questions about how to get that formula in there if you want? The key here is you have to do a few calculations so you can make a graph. So I'm going to zoom out and make my graph. Charts. Change the type to scatter plots. Right. So what I should find is as she drinks more, her blood alcohol level goes up. Is it going up in a straight line? Yeah, it's going up pretty straight there. And that's typical. More drinks, more intoxication. And so then we can answer some questions based on that. So about how many drinks is it going to take for her to be over the legal limit, according to this data? So legal limit, so here's the BAC on the side here. 0.05, that's okay. 0.10, that's too high. So somewhere between 2 and 3 drinks, she's going to be over 0.08, which would be around this high. So if she has 2.5 drinks, she should not be driving. All right, other questions on the worksheets? Oh, we're changing the number of drinks then. So yeah, so for this woman, this is important. In this case, where the formula is set up so that 2 hours have gone by, that's where the negative 0.03 comes from. And then we're letting the number of drinks vary. So notice in my spreadsheet, drinks is my column for the X values, and then I'm calculating the BAC. And I'm measuring her BAC at 2 hours. So if she has 2 drinks 2 hours later, 1 drink, sorry, her BAC 2 hours later will be 0.017. If she has 2 drinks 2 hours later, it'll be 0.064. 3 drinks 2 hours later is 0.111. That's what we're calculating here. A little bit different scenario than we got. 2 hours is fixed, it's the drink that vary. So we're projecting a scenario. So after 3 drinks in 2 hours, is she safe to drive? You will not do well. Danger. All right, I want to go back and look at the male for a minute. So for the male, we had the BAC was equal to negative 0.015 times time plus 0.104. And this equation right here is a lot like equations of lines, y equals m times x plus b. And I talked about this a little bit yesterday, that number m here, that's known as the slope. The idea of rise over run. So this is like the big topic of this chapter. I'm just going to, whoa, extra mark there. So I'm going to grab his graph so we can take a look at it. Make it visible. First, so take a look at the graph that you drew on page 2, I think it was. If you didn't draw one in there, you have it on your spreadsheet, then just look at the spreadsheet if you didn't draw one in. But if you did draw one in, take a look at that. So question number 6 is what my graph refers to here. I'm just going to blow this up a little bit. So to get from one point, let's say this one right here, over to this point right here, I have to drop down a little bit, and then I have to move over this way. So this right here is called my rise, and sometimes the rise is a drop, and this one right here is called my run. Now my run is definitely going from 2 hours to 3 hours, so my run here is just 1 between those 2 points. Yesterday we calculated the change in blood alcohol for an hour. That was question number what? Number 5, maybe? How much does the student's BAC change each hour? What do we get there? Yeah, it drops by 0.015, which, you know, coincidentally, that's this number right here. It's the number I'm calling the slope. So if I look back at my graph here, the rise is that 0.015, and more technically, it's really a negative. That negative means the drop. The negative here equals a drop. Now, when we looked at this the other day, we checked out, for example, our table had 3 hours and our table had 5 hours. Anybody remember what we calculated as the drop for 3 hours? It's negative 0.03, wasn't it? What's the run when I go from 3 to 5 here? 2? I'm going from 3 to 5. So the slope here says from these 2 points, says drop 0 points to get from 3 to 5 on number 6. So you don't have it drawn in here. Yeah, that was for 1 hour. Yeah, so now I'm going from 3 to 5. What's my drop? What's my run here? 2. Okay, whip out your calculator. What's negative 0.03 divided by 2? Negative 0.015, yeah. So if points line up, no matter which 2 points you pick, if you take the rise and you divide by the run, you always get exactly the same number. That number is called the slope. And if things line up, it has to have a fixed slope. The slope is always going to be the same. Even though the rise and run can be different, the slope will be the same. So this is an important idea. And we're diving into this more in worksheet 3, which we're getting started on now. All right, so let's take a look at so if you haven't looked at the homework for 3.2, look at that. We can go over it tomorrow. I want to take a look at some of the prep questions for 3.3, and then I'll get the worksheet out at the end of class. So question number 1 here, I'm going to pop this into a new window so it's easier to see. Problem is going to be a little bit different, but here's what I got. I have Ben has $85 in his savings account, and he plans to deposit $35 a week to build up his balance. So what we want to do is we want to build an equation that talks about the amount of money he's going to have over time. So he's starting with 85. He's going to do $35 per week. Ben's savings. Again, he's starting with $85, and then he wants to deposit $35 per week. And we're going to try and write a formula for what we're going to call A, just the amount of money in his account. So one thing he has is a fixed amount. The other thing he has is a variable amount of money going in. So we're going to have A is going to be one variable, the amount in the account, and X is going to be the number of weeks. So first thing I'm going to do is I'm just going to build a short table based on this for X, the amount of weeks, and the amount. So before any weeks go by, he's got $85 in there. How much is he going to have after 1 week? $120. Yeah, 85 plus 35. How much is he going to have after 2 weeks? 155, add another 35 on there. How much is he going to have after 3 weeks? 190. And so the key here is that all we're doing, and again, this is kind of like the patterns we looked at in 3.1, we're just adding 35 over and over again. Add 35. Add 35. So repeated addition is really what? Yeah. It's multiplication, right? Yeah, so what's going to happen here is for my formula for A, I'm going to have 35 times whatever the stage is, and here my stage is in X weeks, so 35X has to be in there. But then I have the starting point, so I have to add that on, 85. So this is his formula per week. Right, does that make sense? 35 times the number of weeks, and then we just add on that initial amount. And this is a lot like the formula I mentioned earlier, y equals mx plus b. With me here? Because you're acting like it's a Monday. It's Tuesday. You right? Breathe it?
I was thinking it was Monday.
You think it was Monday? So which numbers are slope here, the 35 or the 85? The 35, yeah, and up here, it's saying the rise is 35, and the run is every 1 week. Right? So as far as slope goes, considering that our m, we consider that 35 over 1. $35 rise every 1 week run. Okay. We're just going to be playing around with situations that have a fixed change over time and see what happens with them. Okay, so I'm going to shut up for the moment here. You guys, we're going to double check you finished up activity or lesson 3.2. I'm going to go grab lesson 3.3 for you, which will formally start tomorrow. And then otherwise, you need to finish up homework for 3.2. And tonight, if you haven't started the prep for 3.3, you want to do that. So if you have a question, let me know, and I'll be right back. You don't know. Yeah. So it doesn't. So you got to write stuff down. So you got to do too much in your head. So let me write one of those up here. I'm going to new page. So read me that one you have. So this is the 3-3 homework or 3-2 homework.
3-2 homework. 6x minus 5.
Yeah. So for this one here, same question. So here, I want to get x. So kind of like before, if I knew what x was, I would multiply then subtract. To solve, I have to do that in reverse. So first, I got to get rid of the minus 5. So to get rid of a minus, I add 5. So you definitely want to write these down and not try and do it in your head. For solving an equation, you do the opposite operation in reverse. So I'm going to get rid of the minus 5 by adding 5. So that's going to give me 6x, because minus 5 plus 5 goes away, 0. On the other side, I get 15. Then to get rid of this multiplication right here, I have to divide by 6. Side, 6 divided by 6 gives me 1x, or just x. And then I have to figure out what to do with 15 over 6. So either I could plug it into my calculator, or I could try and reduce it. So if I reduce it, I could note that 3 goes in the top and bottom. The 3 goes in the 15 5 times, 3 goes in the 6 twice. If it was a fraction, it could be 5 halves. Or if I whip out my calculator is probably going to say this is 225. So either answer is acceptable. So if it's not one of those that you can just look at and do in your head, then write it down, and you gotta, I have to do those steps to get it right, otherwise I screw it up. Oh, I have a whole bunch of stuff to get back. Where did I put it? Roberts. Sure, yeah, development 32, what we give it to you now. And we'll check the grade book, make sure you're not missing anything. And then if you are, get it done. If it's my mistake, let me know so I can fix it. Have a good evening.